Hello, friends. You are welcome to another session on Code with Math. If you are yet to subscribe to this channel, please kindly hit the subscribe button and be notified anytime I release a new video. And if you enjoy what you watch on this channel, if you are learning through this channel, please help me and click the like button so that I can reach out to more people, and also you can share with your friends and with your loved ones. Thank you very much. Just in case you are watching for the first time, this is a continuation on the series on learning how to code in C, which is a video I've prepared for beginners and also for intermediate and advanced who will like to refresh their knowledge on C programming. The last time we looked at data types and variables in C. Today we are going to build on that knowledge and we are going to understand operators in C. If you have checked one of my previous videos on anatomy of a C program, I mentioned and I described what operators and operands are. So just a brief refresh. I compared operands and operators to English language. So in English language, you have a subject, you have a verb, and then you have an object. And then sometimes you can have a subject and a verb. So in what way does that compare to C programming? In programming language, your operands are your subjects and objects, and then the verb, that is the action that the subject will do, is your operator. So I went ahead and I made us to understand that there are two types of operators. There are two types of operators. They could be unary and binary. That's when you classify them based on how many operands that are required. And of course, you could also classify them further based on their usage. You could classify them into the arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and miscellaneous operators. So this classification, I got this classification from Tutorials Point, which is one of the resources I used to learn and understand C language. Arithmetic operators. So in your normal everyday arithmetic in mathematics, you will come across a lot of operators like the addition, subtraction, multiplication, division. Then you have the modulus, and then in programming, especially in C language and some other languages, you have the increment operator, where you have the plus plus or the minus minus. So for a better understanding, I would want us to dive into code. So I've created a file here, and in this file, I've named it operators.c. The first thing I want us to understand is, of course, we would have come in contact with the addition, subtraction, most likely the multiplication and the division. So just quickly, I'm going to declare and initialize two variables. So I'm initializing a to 10, and then always remember the semicolon, and then I declare b and initialize it straight to 5. So let me just go ahead and let's print an output. So let's use printf %d and then a new line. So right here we would have, we just want a plus b. Okay, so of course you expect 10 plus 5 to be equal to 15. So let's compile GCC operators .cs, and then we output it to add. So by the time I run add, you see we get 15. Then I can comment this out. Sorry. And then let me have a new line. Printf still dealing with integers, right? %d, new line character. So this time around, I want a minus b. So a minus b should give us 5. So let's compile again. This time, let's use sub for subtraction. Oh, we have an error. What could be the error? Error expected a statement at the end of input. Printf. Okay. Okay, guys, sorry. The closing semicolon and the closing bracket was removed. That was an error. So now it compiles successfully. Let's run sub. So of course we get 5. Okay, let's compile this. Let's comment this out. Printf %d again. So this time around we will try multiplication. Multiplication a. Okay, guys, so multiplication is asterisk. You use asterisk for multiplication, just in case you don't know that before. And then we try to compile this again. Oh, sorry. I want to name it more. Okay, so let me run more. So 10 times 5, 50. Then, of course, we could comment this out. Then I'll just paste this here. And this time around, we will divide. Okay, so we run div. So of course, 10 divided by 5 is 2. So what if, I just want to let us see something. What if B is not 5, B is 4? So of course, if you want to get 10 divided by 4, if you are calculating 10 divided by 4 with your mathematical arithmetic, you would expect to have a value like 2.5. So let's see what this would be. Let's compile again. So you see, we still get 2. So the question is, why are we getting 2? I want you to see that this is an integer. This is also an integer. So how do we get the exact value we want? 2.5. So let's say, what if we change this to float? Let's see this, whether this would work for us. So, ooh, it says this is a double, right? And these are integers. So then this is going to bring me into the concept. There is a concept of type conversion. So I can convert this type. Type conversion is something you would always see in different programming languages. I can convert either of them to a float. Either of them to a float. So by the time I run this again, you see we get it compiled successfully. And then I can run this div. And of course, 2.50000. Remember from the last session we had, I can change this. I can add my precision points. I want it to just give me 2 decimals. Let's compile that again. Okay, so we get 2.5. Okay, so I just want to revert back a little bit so that we can understand the modulus. So I remove this, and then I take this out. I change this back to D. So we deal with integers. So now, if I compile again and let's run the code, and then we are back to 2. So guys, if you do 2 times 4, what you get is 8. So that means 10 minus 8, 2. So that means we have a remainder of 2. So then this brings me to the modulus operator. So to do this, I'm going to do something here. I'm going to put this word division. And then I'm going to print another line. This time, modulus. So for the modulus, use this percentage sign. So what this does is, the explanation of the modulus is that it is going to give you the remainder after successfully dividing your your left operand by your right operand. So it's going to give you the remainder. So in this situation, the first line of code, this line of code is going to divide 10 by 4. So in that, there are going to be 2 successful divisions, right? But there is going to now be a remainder of 2. There's going to be a remainder of 2. So this is just going to print out the remainder. So let's put our code into a test. So mod now. Let's run mod. So we see division 2 and remainder of 2. Okay, so let's do something. Let's put this back at 5. So we expect that 10 is divisible by 5, right? So 5, 5. So that's 2. And then there will be no remainder. Let's see what the value of the modulus would be. So I need to guess what the value would be. Think about it, and let's check what the value would be. Oh, sorry, another typo. Okay, so division, the result of division is 2, but then the modulus gives us 0, so the remainder is 0. So when you have successful divisions, right, there will be no remainder. The remainder becomes 0. So let's go to the next operator. Right here we can see the increment and then the decrement. Plus plus, minus minus. I think I will just take those two together. Plus plus, minus minus. So which stands for increment and decrement. Back to our code, I'll just comment this out. So I think I'm having a glitch with my computer, but everything is okay. So permit me to I'm going to paste in yes and note. Okay. All right. So the first is this plus plus a. So let's do plus plus a first. So plus plus a. So it means first increase. So when you have the plus plus coming before the variable, first increase the value of the variable by 1. Then use the value after the increment. The next, when you have the a plus plus, that's the variable, then plus plus, then the increment, you're saying first of all use the value of a at its present value. So use a at its present value, then increase by 1. Then of course the decrement, the same. So when you have minus minus a, so you're saying first decrease a by 1, then use it after the decrement. Then a minus minus, you're saying first use a at its present value and then decrease by 1. So let's see this in action. So I just want to do a printf. Then let's just do %d, and of course a new line. So we go to what I want to use a, right? So I want to do a comma a. So I want to first do a plus plus, then plus 4, sorry, plus b. So right now b is 4, a is 10. Okay, so now with what I explained here, so this is a plus plus. So what this is going to do is it's going to first of all use a. So a is 10 plus 4. So if you are guessing the answer of this should be 14, then you are correct. Then I want us to see the value of a after this present action. So let's printf again. Send d, a new line, a. Okay, so let's run this code. and then I'm going to output it as ink, right? Let's do ink 1. So let's run this ink. So you can see the first line outputs 14 because we are using A. So the A presently is 10. So we use A, we added A to 4. So 10 plus 4 is 14. But then after we use that value of A, we increased it by 1. So on this line, A becomes 11. 10 plus 1 becomes 11. So let's comment this out. Let's comment this out since I'm still using A. Let me just stick to this. Okay, so printf, still using %d, new line. So this time around, I want to do plus plus A plus B. Of course, we left out a comma and then a semicolon. So then, I want you to pause. I want you to explain this code. Try to get an output. Then, let's see the output and then let's see whether you were right. So this time around, we'll call this ink2. Let's run ink2. Okay, so remember on this line, A is 10. Here, B is 4. So when all of these are neglected because they have been commented out. So that's another use of comment. When, for example, when you are debugging and you don't want your code to, you don't want to run a particular code block, you can just comment it out. So on this line, we want to print the result of this. So this is saying, first of all, here, first increase the value of A by 1. So A is 10. So we increased 10 by 1. So this gives us 11, right? So 11 plus B is 4. 11 plus 4 is 15. So that's why we have this output, 15. And then we now print A right here. So we see A is 11 because it was increased right here. So, and of course, you can have something like this. Let's just play around. One of the things I like doing that helps me to learn is just to play around with code. So I'm trying this for the first time to see if it's possible. So it's not possible. That's why there is a red here. It's not possible. So it's not possible for you to post increment and to pre-increment, that's, and post increment at the same time. So it's not a possible thing to do. So just for you to note that. All right. We can try the decrements. Let's try the decrements. So we still use printf. Okay, just to be faster, I'm going to copy this. Of course, remove this. So let's first try this. Minus minus A, right? Minus minus A. So I want you to also pause and take a look at this code. What do you think the output would be? Just pause the video and try to think of the output without running it yet. Then let's run it together. So printf minus minus a. So we are saying, first of all, decrement a by 1 before you use it, right? So first decrement it, then you use it. So we decrement by 1, a is 10. So by the time we decrement by 1, a becomes 9. So 9 plus b, which is 4, that's 13. So we expect that the value of a here would be 9. So let's run our code. Of course, we call this deq1. And then let's run deq1. Voila. So we get 13 and we get 9. Okay, so a was decremented before usage. So let's use this now. Let's do the opposite of this. So of course I comment this out. Then this a minus minus. So remember, a is 10 from the 4, right? So by the time we do, so here we first use 10, then we decrement 9. So we first do 10 plus 4, 14. Then by getting to this line, a has been reduced. So a becomes 9, right? So let's print this out. So deq2. So you see we have 14 and 9. So 10 did not change here, right? But after we used it, we decreased it. So it became 9 on this very line. All right. So that is it for the arithmetic operators. I would want us to pause our session here. So we're going to stop this very session right here so that we don't have too long a video to watch. Okay, so I would continue from here next time. I'm going to consider other operators, right? Starting from relational operators, we'll look at logical operators, we'll look at bitwise operators, assignment operators. So, but right now we're going to stop right where we are, and then we will continue next time on this same channel. Thank you very much. So if you are yet to subscribe to this channel, please kindly hit the subscribe button. And if you like what you've watched today, please kindly click the like button and help me to reach out to more people. Share this video also with your friends so that we have more people learning together. Thank you very much. I love you guys. Bye for now.